Protein synthesis by Mohammed. I'm going to talk about how DNA can end up making proteins. You may be wondering, what's the big deal about proteins? Actually, they do lots of things for your body, such as transport, structure, protecting the body, and much more. Actually, your body's making proteins as you're watching this video. Your cells are making them. But let's go back to the DNA. So most of your cells have DNA. It's in the nucleus. Some DNA is non-coding DNA, but I'm going to talk about DNA that codes for active proteins. So how are we going to get the information from inside the nucleus out of the nucleus to make DNA? Well, that's where RNA comes in. RNA is a nucleic acid like DNA, but it has a few differences. RNA plays a huge role in protein synthesis. In protein synthesis, there are two main steps: transcription and translation. Transcription is when we get to transcribe DNA into a message. In your cells, the DNA is in the nucleus, so therefore we're doing transcription in the nucleus. In transcription, an enzyme called RNA polymerase will connect RNA bases to the DNA to make mRNA. In mRNA, the M stands for messenger RNA. In eukaryotes, the mRNA gets to go out of the nucleus and into the cytoplasm and attaches to a ribosome. Ribosomes make proteins. Ribosomes are made out of rRNA. The R in rRNA stands for ribosomal RNA. The ribosome is going to build the protein in the next step called translation. In the cytoplasm, there are lots of tRNA molecules available. tRNA stands for transfer RNA. They have an amino acid on them. An amino acid is like a building block for proteins. If you have a bunch of amino acids together, you can make a protein. So it is the tRNA that is going to bring those amino acids together to make a protein. But how does the tRNA know which amino acid to bring? That's why the mRNA, all of the tRNAs are looking for matching bases. When they find the matching base on the mRNA, they transfer their amino acid. When tRNA is bringing in the bases, it reads the bases in threes. These three bases are called codons. The bases on the tRNA that match that base are called anticodons. For example, in this situation, the codon would be AGU and the anticodon would be UCA. All tRNAs with the anticodon UCA will have an amino acid called serine. A tRNA will eventually leave, but it will leave behind its amino acid. Before I go into the next codon, you may be wondering, how did I know that the tRNA with the UCA codon would be carrying an amino acid called serine? Well, for that, you would need a codon chart. You can learn to use a codon chart to see which amino acid each mRNA will code for. As you can see on the codon chart, the codon UCA codes for an amino acid called serine. Also, there can be more than one codon that codes for the same amino acid. For example, according to the codon chart, all of these codons code for the same amino acid, leucine. So let's go back to the mRNA. Let's try the next codon, UAC. On the codon chart, you can see that UAC codes for an amino acid called tyrosine. Usually at the end of mRNA, there will be a stop codon. Stop codons do not code for an amino acid. It's just telling the ribosome that the protein is done being made. Usually at the end of the mRNA, there will be a stop codon. Stop codons do not code for an amino acid. It's just telling the ribosome that the protein is done being made. For example, if tRNA reads UGA on the codon chart, that says stop and indicates that the protein is done being made. Now obviously DNA is the director of this whole process, but it couldn't have done it without the help of mRNA, tRNA, and rRNA. That's it for me. Goodbye.